Engineering doesn't start with finished products. It starts with curiosity, experimentation, and the freedom to iterate.
We're going through robots very quickly. We go through about maybe 6 prototypes throughout the season.
3D printing allows us to get an accurate shape, and then we can also design how the mold bolts together.
Prototyping, iterative design is a key component of our curriculum.
The mental process of designing something, knowing that you can print it, is a whole different game.
Welcome to Engineering Unlocked, a series exploring how hands-on learning, accessible tools, and real-world problem-solving are shaping the next generation of engineers. Presented by DigiKey, powered by Microchip, Molex, and Supplyframe. On the campus of Cal Poly in San Luis Obispo, students are putting rapid prototyping into practice, testing ideas, refining designs, and moving quickly from concept to execution.
The motto at Cal Poly is learn by doing, and one of the ways that learn by doing manifests here is that for every hour of lecture, we have an hour of lab, creating spaces like the makerspace where we have the capabilities, the components to come together and make those cool robots.
Inside the makerspace, 3D printers run non-stop. Students design, print, and test parts for the school's Formula Racing program, making fast adjustments and applying them in real time.
This space is funded by all the colleges on campus, so it's not just engineering. And so we have a lot of architecture students coming through and art students. We have pretty prolific Formula and Baja teams.
This is our formula car with all the components. Isolating it down to the chassis, this is what we make out of composites using the machine shops here. We're able to machine about 95% of our entire car in-house. I printed these this morning and I already have a prototype ready. We're one of the only teams in California that does a carbon fiber monocoque. You have a lot of interesting geometry, so 3D printing allows us to locate everything super precisely.
Right now, to come in and use filament, it's free. Up to 500 grams per print, which is half a school. And it's really empowering to see people's eyes light up. It's like, oh wow, I can make anything.
This is basically the brain of the entire thing. All of this is mostly designed in-house, especially because we're working with a lot of varied types of connections and functionality. A lot we just have to strip wires and custom solder in.
You essentially adjust the RC time constant, and the higher the resistance, the faster it goes. 555 counter and a gate driver.
The workshop that I held last quarter was a breathalyzer workshop. The presence of ethanol in the air would determine the output voltage of the sensor. The microcontroller interprets that reading as ethanol and then displays it on an I2C OLED display.
Across campus, engineering students are building custom electronics, while computer science students work alongside hardware, collaborating across disciplines to bring systems together.
Our team competes in the VexU robotics competition. This year's game is called Pushback. We're competing 2v2 on a 12 by 12 foot field. There's the goal on the bottom, there's the mid goal, and then there's the long goal.
We have this really cool mechanism here. We spin it this way to score in the middle goal.
Spin this roller the other direction, plus this roller, and they'll shoot down the long goal.
If your blocks are between these two tape lines, you get a bonus of 10 points. Our drive team members spend many, many hours practicing, making sure that this piece gets lined up on the goal, and they can do this every single time.
This year we're planning on doing a badge for the Noise School Computing. It connects via Bluetooth to have lighting effects.
I got interested in this club because I wanted to learn more about the hardware and the PCB side. For me, going from Inkscape to KiCad is definitely an easier pipeline than the other way around because it lets me do something I'm more familiar with and then learn new skills on top of that.
These experiences point to a larger shift. Engineering tools are more accessible, iteration is faster, and the distance from idea to prototype is shorter than ever.
It's really fun to see all of the students come together in sort of a near-peer environment. Rapid prototyping, you can come out with some really creative ideas.
The maker movement is like the opposite of gatekeeping. It's like the gateway into being able to learn things, to be able to accomplish stuff without having to be an expert necessarily.
Making it accessible for newcomers, for people who may not be that tech savvy, but want to get to work right away with it.
There's so many amazing things we see out there, and they just come out of weird places. Someone might start off with a simple tutorial, and they just build off of it and grow and do some kind of weird jazz thing on developing stuff.
Create your prototype, but then develop the people skills needed to sell your idea. Go to conferences like SuperCon, where you can meet people who might complement you.
I've got this inspiration, I've got this idea. I know that I can make it work. How do I get that? Well, DigiKey will help you get there.
If you want anything to function correctly, especially out in the field where there's so many different elements, different things that can happen, you have to be able to rapid prototype.
The future of hardware belongs to those who learn by doing. This is Engineering Unlocked.